your unit circle. Now the unit circle is not part of the curriculum. Okay, it is a tool that helps make this stuff a lot easier. So it won't be on your formula sheet for your, Ken, can you just concentrate here, please? Where's your notes? It won't be on your formula sheet for your diploma because it's not universal, okay? But my best advice to you, as soon as you get into the diploma, draw a unit circle, okay? So I'm going to teach you strategically how to draw a unit circle because you don't get to take one in grade 12. You never get to have your unit circle out during quizzes, okay? You have to know your unit circle. And when you get good at it, you can actually draw an entire unit circle in under a minute. So with that kind of investment, that's not a huge investment when there's going to be 4 questions on the diploma. Okay? So as you can see, with the unit circle, it has all of the stuff on it. It used to be only in the grade 12 curriculum, and they finally brought it down into grade 11. So at least we did the unit circle with degrees. And what I'm going to, now if we go now to page 534, now here is what you have to know. You have to know every single number on here. And that seems overwhelming, but it's kind of like anything. If you invest your time to learn this, the rest of the unit is quite easy. If you don't invest the time to learn this, the unit is quite difficult / impossible, okay, and extremely time consuming. So I've got a blank unit circle there for you, and what I want to do is I want to be able to show you how to be able to do a unit circle kind of strategically more than memorization. Now, the first thing we're going to deal with is all of the 45 angles, or the pi over 4s. So you take your unit circle, and you've got a ruler, so we'll do it in black, but I want you to cut right down the middle of each and do your 45s. Oh, bad. Okay, so just do that quick. Now, at every single line now, you doing this with us? At every single line, at every 45, it's always over 4. Okay? So pi over 4, 2 pi over 4. So this is how we're going to start it. You always start here. Okay? This is pi over 4. This is 2 pi over 4. Or I could say 1 pi over 4. This is 3 pi over 4. 4 pi over 4. 5 pi over 4, 6 pi over 4, 7 pi over 4, and 8 pi over 4. So when I ever get the unit circle, or whenever I get a question, right, I've already got this drawn. So now I know you've seen some of these, like this reduces to pi over 2. And if you look on your unit circle, that's what it says. It says pi over 2. It doesn't say 2 pi over 4. But I know you guys know how to reduce quite easy. This is just a fast way to do it. Now, let's do all of the 30 degrees. Okay? Now, the 30 degrees kind of run like this. And for each 30, not missing the x or the y-axis ever, we're going to count over 6. 1 pi over 6, 2 pi over 6, all the way to 12 pi over 6. Okay, so this is 1 pi over 6. Now don't touch the 45s though, you already did those. This is 2 pi over 6, 3 pi over 6. Now you see how we've done that one twice? But that's okay, they still equal pi over 2, don't they? 4 pi over 6, 5 pi over 6, 6 pi over 6, 7 pi over 6, 8 pi over 6, 9 pi over 6, 10 pi over 6, 11 pi over 6, see there it is, Gina, and 12 pi over 6. Now you've memorized all the radians in the unit circle. So you count over 4s for your pi over 4s, and you count over 6 for your pi over 6s. Every question that they're going to ask you will be one of these. So I'm just trying to kind of take what maybe look like it's just like someone waved a wand or something and made this unit circle, right? It does have a reason behind it. Now all of your 45s are all root 2 over 2, root 2 over 2, right? This is root 2 over 2, root 2 over 2, but it's in the second quadrant, so x should be negative, right? This is root 2 over 2, root 2 over 2. They're both negative here. And root 2 over 2, root 2 over 2. Only the y would be negative there. But it's just good to know that those are all root 2 over 2, root 2 over 2s. And the tans are always 1, negative 1, 1, negative 1. So it's always cosine tan. Cosine tan, cosine tan, cosine tan. Or you can make a little legend somewhere that cos always equals the x, sine always equals the y, tan always equals y over x. Okay, and then you know that this is, when starting from the x-axis, this is 1 comma 0, 0 comma 1, negative 1 comma 0, 0 comma negative 1. Tan is 0, undefined, 0, undefined. Okay, and next we just have to fill in the 30s, right? So this is root 3 over 2 comma 1/2, and then it's a flip of the other one. It's 1/2 comma root 3 over 2. The tan here is root 3 over 3, and tan here is root 3. Now all the rest are complete reflections. Just change the sign. Like this would reflect over to here, right? So that's still 1/2 root 3 over 2, and then root 3. Just make sure that your x is negative, and so will your tan be, because you're going y divided by x, right? This one flips over here, so this is still root 3 over 2, 1/2. But that's negative, and then this is negative root 3 over 3. Okay, these two will be the same, and these two will be the same. but different signs because they're in a different quadrant. So this is still root 3 over 2, comma 1/2, root 3 over 3, but the y will be negative, and so is the tan. This is 1/2 root 3 over 2, y will be negative, and this is root 3. Yeah, and it'll make even more sense when you do it again next year, right? That's what I'm hoping for you. Obviously, I am not. I hate make work projects, you guys, more than you know. So I'm not doing this just to keep you busy. Now these two will be the same: 1/2 root 3 over 2 and and root 3, but they're both negative here. And again, this is coming over here, and this will still be a reflection this way and this way if you want to look at it. You can see how once you put it all together, it looks like this overwhelming mess again. Okay, this is root 3 over 2, comma 1/2, root 3 over 3, and they're both negative. So I think it's pretty obvious. So when you look a unit circle at once, it is an overwhelming amount of information, and it is. So what I'm going to show you is I would just do all of my pi over 6s, all my pi over 4s, and just do the quadrant 1 on my, if I was writing a test. Then when they start asking me something in quadrant 2 or 3 or 4, I'll just do that quick. Okay? And I'll show you some strategy how I do it. I always draw it. Every single time I'm asked a question, just go 1, 2, 3, 4, 5, 6, 7. I write the x and y and the tan, and then I got my answer. So I always do my questions just like we build them here. So this is a necessary exercise. Right? At the first you're going, I already have a unit circle. Like, why am I drawing one? I don't need to draw one. Because I want you to understand how it was built. I want you to understand why those numbers are there and how they got all of the, because some are over 2, and some are over 3, and some are over 4. Well, actually, no. All the 45s are over 4. They reduce the fraction after. And all the 30s are over 6. They just reduce 3 pi over 6. That'll be pi over 2. The 4 pi over 6 will be 2 pi over 3. 5 pi over 6 doesn't go anywhere. You can't reduce it. 6 over 6 is 1, right? So you can see that they all came from over 6s. Now this is just the way that I have found a way to actually understand it and learn it. I mean, the next math teacher would maybe just say, memorize it. And if you memorize it, it is, it's easy in, easy out, right? You forget it. As soon as it is to memorize it, it's that fast to forget it. Okay, now let's go back to our lesson, and let's go to the next page, and let's look at, now if you've drawn your unit circle before you start, you probably wouldn't do it the way I'm going to show you, but this is how I would do it. Cos 3 pi over 4, I would go 1, 2, 3, sorry, 1, 2, 3, there I am, 3 pi over 4, right? Why did I know that? They always go over 4s, and this is, okay, root 2 over 2, root 2 over 2, and that's negative, right? And cos is always the x. I'm on page 535 for people that are wondering where I am. So here's my answer, negative root 2 over 2. Now, 5 pi over 3, what is that really on my unit circle? Because mine are all over 6, right? So it is 10. So it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I'm right there. Okay? So this is, okay, now it's cotan. So that is negative root 3 for tan, correct? So I've got to do 1 over negative root 3 for tan. or for cotan, sorry. And if you rationalize the denominator, you get negative root 3 over 3. So this is exactly how I do them. If you said, hey, what's this? I'd be like, just a second. And then I would do it, right? So I like to know it more than memorize it, right? Some people, like my wife, you could ask her a phone number from like 10 years ago and she'll give it to you. Like that's her strength, right? I'm like, I can't remember a name, right? My son, who's like 10, you know, will be walking, there'll be someone coming and I'm supposed to know their name. I'm like, Dad, what's his name? And Tad will be like, he'll shoot it out right. I'm like, hey, good, right? It's like I freeze. It's like, oh, crap. I can't remember names. I can remember everything about that person, everything they've ever done. I can't remember their name. Now, so I just choose to. Now, let's look at example 4. This is a very high-end diploma question if you don't know your unit circle. Where is this hanging out? Which quadrant for sure? Four, wouldn't it? Yes? Yeah? Because you got a negative y and a positive x. And it's at a 45-degree angle, or pi over 4. So this is P. And Q is negative a half root 3 over 2. Second quadrant. And it would be up here, would it not? That's Q. Now, if the object rotates counterclockwise, okay, so look at the clock. That's the way it's going. So counterclockwise is this way. So how much is, and they want to know what angle did it rotate? In radians and degrees. But let's do it in radians. How much is here? How much is here? Just this little part. No, the angle. In radians. Come on, you guys. It's a root 2 over 2 root 2 over 2. They always go by. So this is pi over 4, right? How much is this? 90 or pi over 2 or 2 pi over 4. How much is this? Come on, what's a 30? Pi over 6. So we got a pi over 6 plus pi over 2 plus pi over 4. Okay, if you think this is stressful this year, right? It's not going to hurt you this year, right? It is stressful next year when you're not getting this. When you see it for the second time, it's familiar and it's very different. Now, does everyone see how I got my pi over 4? Pi over 2 and pi over 6, okay? We can't add without a common denominator of 12. This front row here is not really batting very well this morning. Okay. 4 seems like it should go in 18, eh? But it doesn't. It doesn't. Okay, so this would be 2 pi over 12, 6 pi over 12, and 3 pi over 12. So 2 and 6 is 8, plus 3 is 11 pi over 12. And degrees would be quite easy, right? You could do degrees well. That would be your 45, that would be 90, and that would be 30. So that's 165 degrees.
If we just labeled it like 10, 11, 12, then how, what's a good way to find the pi over 4?
Okay, well this is 11, or no, sorry, this is, This is 7 pi over 4, right? This is 8 pi over 4. How much happened? How much between here and here? 1 pi over 4. That's good. I like those questions because they're
If you just went from 7 to 8, then just
7 pi over 4 to 8 pi over 4, you went up by pi over 4. Okay, without a graphing calculator, the exact value of log 2 cos 7 pi over 4. Okay? Now you haven't learned logs yet. Yeah, it's not like that, because every time I teach logs, people go, oh, I wish we would have known that for chemistry. And yet they've already had Chem 30. So you guys do, I'm not going to go into it into detail, but let's just do the cos 7 pi over 4. What is the answer? So we're here again, aren't we? Which is root 2 over 2, root 2 over 2. That's negative. So how would I really do it? I mean, we just did it in the last one, but I'd go 1, 2, 3, 4, 5, 6, 7. Right? So I know I'm there. I know because it's 8 pi over 4, it's always root 2 over 2, root 2 over 2, and it's in that quadrant. So that y is negative. So I use the cast rule. I count by ones over 4, which I'm pretty good at. I don't like to brag, but I'm pretty good. You've been seeing me. I'm good at that. And I can draw, not very well, but I can draw things that look like they're sort of there, right? So you take all of those talents, and I can do these. And you can too. Now, which one's cos? Root 2 over 2. So that's just your answer, root 2 over 2. So I don't like to throw this word out loosely, but these can be fun if you know your unit circle. Long story, okay? You know when you asked your mom how her baby's made and they're like, you just wait, okay? Wait a few years. That's the same thing about logs. No? You should get around to that. I'll give a call home and say, you know, Rutho, he was asking and I'm thinking I didn't. Okay, let's go over here to, now this whole page deals with memorizing this chart. Okay. Now, here's what you always have to know. If it's on the unit circle, this formula will always work. X squared plus y squared equals 1. Why does that work? Because r is 1 on the unit circle. Only on the unit circle, r equals 1. So a simple question will be, is 1/2 on the unit circle? Now, the first thing you're going to think is, no, that's not one of my things. Okay? But there's a billion other points that are actually on the unit circle that you don't have to have memorized or know. But you still want to test them. So is 1/2? You don't want to jump to conclusion and go, no, those aren't the ones I had to memorize. So it's not, okay? No, you want to test it in here. So you'll go 1/2 squared plus 1/2 squared. We want to see what that equals. Because if it equals 1, then I'm good. So 1/2 plus 1/2, that's 1/4 plus 1/4 equals 1/2. 1/2 does not equal 1, so no, it is not on the unit circle. Okay, now let's do one that doesn't appear to be, which is B. B and C are both on the unit circle. Actually, let's do C. It's got radicals in it. I know how you guys love those. So, -2/3 squared plus root 5 over 3 squared. So that is -4 over 9 plus 5 over 9. Oh, sorry. When you square, it's positive. I was like, what is going on here? I know. Well, you're a little late. Late to the party. I'd figured it out already. 5 seconds ahead of time, you might have been able to show me up. You were way too late. Okay. So this is 9 over 9, which is 1. Okay, so this is a yes. It is on the unit circle. Okay, this one says this point is on the unit circle in quadrant 3. So a lot of information there. It wants to know why. So get it in your formula. Negative 1/5 squared plus y squared equals 1. So you'll get 1/25 plus y squared equals 1. Now when you subtract 1/25 to both sides, you will get y squared equals 24/25. Because you're minusing 1/25. Now you're taking the square root of both sides. So if you're doing that, y would equal plus or minus 24 over 25. Root 24. Now, the first thing you have to ask, is it plus or is it minus? Why is it minus? Yeah, if I'm in quadrant 3, y is negative. So it is y equals negative root 24 over 5. I just took the square root of the bottom. Is there a square root in 24? What? 4. So 4 would come out to become negative 2 root 6 over 5. People don't appreciate the unit circle till you spend a little time without it. Okay, just a couple more. Determine the equation of a circle. Actually, yeah, we'll just not do that. Okay. That's what we did, sort of, yeah. So definitely 3 we want to do. 4, I just want you to do, don't do any degree questions because you should know how to do those. So just 4, B, C, and E. Okay, I want you to do 8. 10. And let's just leave it at that. Okay, so you should be able to get it done in class. There's just one more quiz tomorrow, then we're starting review for the, and I will put up your all-in mark at the end of this period, so you can check school zone and be able to see where you stand.